Live from Earth, it's Space Radio. This is Paul Sutter, astrophysicist at Stony Brook University and the Flatiron Institute. And for the next half hour, your agent to the stars. I got an amazing, exciting show for you today where we shall mourn the loss of the Arecibo Observatory and take questions from all y'all. It's going to be we got quite a crew. We got quite a crew today on live right here. Wow, this show lives on listener questions. We record every Thursday at 8 p.m. Eastern here at Spaceman Studios in New York City. So you can leave a voicemail to get yourself on the air. You can also follow along with our space cadets tuning in live from around the world who say space radio, best radio, darn straight. We've got Idaho Falls, Idaho, Howell, New Jersey, Duluth, Minnesota, Marion, Indiana, Kerry, Ireland, Great Dark Sky Preserve I've heard nearby, Washington, D.C., Canada, Australia, Greece, Darmstadt, Germany, Portsmouth, UK, Cheeselandia, wait a minute. Cheeselandia? You just... That's Paul at pmsutter.com, okay? Just hit me up here, all right? And more, Austin, Texas, and more. Check out spaceradioshow.com for all the links to catch the live streams, also the podcast audio version of this show. Man, this is going to be so exciting. And yes, it is Flatiron Institute, not the Flat Earth Institute in New York City. Flatiron is named for the Flatiron Building, which is nearby the Flatiron District in Midtown Manhattan. Not the Flat Earth Institute. I am not associated with anything like that. Look, we got some news. We got a few big stories this week that I want to go over, that I want to chat about, I want to hear questions about. Remember, get your questions over, and then the wonderful Nancy Graziano will copy those over to the back channel. First off, now what I thought was going to be the leading news story this week was that this giant black hole, and so I'll talk about it before I lead into Arecibo here. What I thought was going to be the big news story this week was that, hey, you know that giant black hole at the center of the Milky Way galaxy? It turns out we're a little bit closer to it than we thought. Now, it's not because we're moving in the direction of the black hole. It's because some astronomers in Japan did an updated survey to try to get a better handle on where the galactic center is. And they did this by taking the positions of a whole bunch of stars using a technique, an astronomy technique called interferometry, where they took a bunch of little telescopes and spread them all around a bunch of islands around the Japanese archipelago. I believe the distance was like 2,300 miles. If you want that translated into kilometers, you're going to have to do that yourself. If you want to translate into light years, you're also going to have to do that yourself. So 2,300 miles, which gives you a telescope that is 2,300 miles across, which is kind of large. And they watch these stars wiggle back and forth over the course of a year. This gives them a parallax distance measure. So they were able to pinpoint the distances and the speeds of a whole bunch of galaxies. And then they saw that all these stars are moving in a circle, obviously, because they're orbiting the center of the Milky Way. And then with the updated measurements, they could figure out what that center is. And they put that center about 2,000 light years closer than what it had been before. Oh, and as my mistake is 2,300 kilometers. And if you want that translated to miles, you will have to do your own work. So this comes from the Vera Astronomy Catalog. And yeah, they pinpoint galactic center with a supermassive black hole to be 25,800 light years away. Now, there is uncertainty on that number. It's like 25,800 plus or minus 1,000 light years. So it's not like that radically different than the numbers we've had before, but it is a little bit different. What does this mean? Absolutely nothing. But hey, the news, it's cool astronomy, and the news will report on just about anything. Now, we have to take it down a notch. We have to we have to get a little bit sad here. We have footage. I'm going to play some live footage. Not live right now. This is footage. It's recorded. Okay, so it was live at one time, and now it is no longer live. This happened on December 1st. If you're just listening to the audio, you're just going to have to imagine the scene of a giant radio telescope falling apart. And so here we are. This what happened on December 1st of this year. This is from the Arecibo Observatory in Puerto Rico. Let's just watch. Continues for another, I'm going to mute it here. The video continues for another minute as you watch the dust and debris rise over the jungle. Yeah, it's hard to watch. But here's the thing. This is going to be kind of a hot take for Arecibo. Oh, and there's also drone footage. I'll play that of the exact same thing of the collapse. Oh man, this is even more dramatic. You see, man, I wish you could hear this, because it is intense. So, chat is already asking, space cadets are already asking, can it be rebuilt? It technically could be rebuilt, but we're not going to. So the National Science Foundation, they're the ones who are paying for this, who did do a large chunk of the funding. They haven't been doing a huge chunk of the funding in recent years, but they have been in charge of maintaining it. They had already decided, after they had noted some extensive damage to the area, to the telescope, that they weren't going to rebuild it. And so the collapse was inevitable. That's why they had all these cameras trained on it, just because it was going to happen anyway. And here's my hot take. Slightly controversial. Feel free to fight me on this. It's okay. I don't think it's that big of a deal. I don't think it's a major blow to astronomy. Yes, the Arecibo Observatory. And if you don't know, Arecibo, this is that giant dish that sits in the jungle of Puerto Rico. It is huge. It's like 500 meters across. It's large. This is the famous one. So not a lot of telescopes get to be movie stars. This one did. Arecibo's been in Contact. It's been in James Bond movies. It's been in some other TV shows. It's like, if you imagine in your head, like giant radio telescope that sits in the jungle, you are thinking of the Arecibo Observatory. Chat is asking, space cadets are asking, how long did they neglect it for this to happen? So here's the thing. Hurricanes happened. All right, it's Puerto Rico. It got damaged a few years ago by some hurricanes. It got damaged again by some strong winds. Things were weakening. Things just weren't looking great for Arecibo for quite a few years now. And then finally it was just like, we just can't. We either spend the money to fix Arecibo, or we spend the money somewhere else. And the National Science Foundation decided to spend the money somewhere else. And here's why it's like, yes, Arecibo has been a big deal in astronomy. Okay. There have been major astronomical discoveries made with this giant radio dish. I'm not going to argue that. But that was in the 2000s or like the 1900s. Like this thing is like, what, 50, 60 years old? This is an old telescope. Telescopes usually don't have that long of a lifetime. Even the big ones, even the important ones. Yes, there was Nobel Prize winning work done with this. Yes, it gave us a window to the universe that we didn't have before. But it's 2020, almost 2021. Arecibo isn't at the forefront of astronomical research, and it hasn't been at the forefront of astronomical research for decades. important work has not happened at Arecibo for many, 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 many years. One could make an argument, I'm not necessarily making an argument, but one could make the argument that the only reason we've held on to this telescope for so long is nostalgia. Now, it did play some important roles, and it still does. It's great because it can also beam radio, not just receive radio. So we can use it as like radio sonar, and so we could get images of little asteroids or rocks that are coming close to the Earth. That's pretty cool. We can send messages to aliens as if anyone is listening, which is, in my book, not so cool. Kind of a waste of time. But hey, I'm not in charge of it. But we have giant radio telescopes. We have an even bigger one in China that opened up like a couple years ago. It's called FAST. It's huge. That one's like over a kilometer across, like 1,600 meters across. It's gigantic. It's even bigger than Arecibo. And we have this cool technique of interferometry we've made leaps and bounds with this technology over the past few decades, where instead of one big radio telescope, you have a bunch of little ones, and then they all link up together, and you get these amazing things. Like the Event Horizon telescope was an interferometer. That's how we got a picture of a black hole. You're not going to get a picture of a black hole with Arecibo unless you make Arecibo out of the whole entire Earth. Space cadets are pointing out Arecibo was part of the Santa tracking network, so we will have to lean a little bit more heavily on NORAD as Santa is coming through the North American defense zone. But so that's a small loss. I will acknowledge that small loss. Yeah, like we're not. It hurts me to watch this giant, magnificent structure fall apart. It does, But this is my point. We're not really losing a lot of astronomy. Like the next 10 years of astronomy is not going to look very different than if we had poured that money into Arecibo, because that money is just going to go somewhere else and it's probably going to be put to better use than trying to keep Arecibo going. So that's my take. It's tragic, but like, you know, it's the tragic, like when your grandma dies, but she's like 97 years old. You're like, man, I really miss grandma, but she had a great life. Okay, I really miss Arecibo, but Arecibo had a great life. That is, what a horrible analogy, Paul. Why did I even go there? Is the first one I thought of. Okay. Let's move on to some questions. And Space Cadets, you put tons of great questions in the chat already. I just want to take a quick break and remind you that this show is brought to you by you. Please go to patreon.com/PMSutter. Now, Patreon is amazing, and it pays for my livelihood. I am an astrophysicist at Stony Brook and the Flatiron Institute. Those are unpaid adjunct positions. I make my money from doing this, like hosting radio shows and going on TV and writing books. So it keeps this stuff going. Like if the Patreon shuts off, like I can't do this. I have to do a normal job. And nobody wants me doing a normal job. But as a little incentive, Patreon started this thing where you can do annual memberships. Instead of just paying month by month, you can pay for a whole month upfront. So if you, for December only, if you pay at the $10 a month level, for a whole year, and you click the button that says pay annually and do one lump sum for a whole year, I will send you a free mug that says, if it's interesting, it's probably wrong. I'm drinking from it right now. I can tell you, tested, it does hold liquid very competently, which is the main purpose of a mug. I suppose it could also hold a bunch of pens. If you need a random pen holder, this makes a great holiday gift. And I'll ship it to you. I'll send it to you for free if you do that annual membership at $10 a month or higher. And it's hilarious. It really literally says, if it's interesting, it's probably wrong. If you subscribe at $25 a month, for that annual subscription, I will send you an autographed copy of my book, How to Die in Space. Free. I'll just send it to you. I got a stack of them over here in the closet. I'll sign one and I'll put it in a little bubble mailer and I'll put your address on the top and I'll ship it to you for free if you sign up. Patreon.com/PM Sutter. The M is for Matthew because that's my middle name. You can also just buy the mug or buy the book, pmsutter.com/store. If you feel like it, if you feel like making a gift, it's the gift season for giving. In order to give, you got to get. And you got to get from pmsutter.com/store. Now, but that's enough advertising. That's enough advertising. Yes, we have cheese later, and I'm going to talk about that. Listen, I bet it's been a couple weeks. Thanksgiving happened, or Zoom's giving, which is the reality of the world. I got some voicemail. So let's play one of these questions.
Paul, this is Chris from Atlanta, and you did me a great favor by answering one of my questions on the show a few months ago. Then you thanked me for not cursing during the question. So I'll restrain myself again while I ask this one. It's about the rotation of stars within galaxies. It's easy to conceive of the way that stars rotate in a spiral galaxy. Most of them travel around the galactic core in a disk in basically the same direction. But my question is, how do stars rotate in an elliptical galaxy? Do they have some sort of coordinated rotation, or do they just go all over the place? I'd really like to know, and thanks for answering my question.
Oh, thank you so much, Chris. That is a great question. Thank you again for not swearing. If for those of you who don't remember the last time Chris answered, I played his question live without previewing it, so I was crossing my fingers that there was no swear. So far, no caller has ever sweared. I've had some weird ones that I've not played on the radio because they've just been weird, but so far no one swore, and I appreciate it because we like to keep things family friendly here over at Space Radio, which is one of the reasons Nancy Graziano is monitoring the chat for us. Now, because the space cadets can get a little unruly. Now, great question. Spiral galaxy. Stars are moving in a circle. Most of the stars are not in the spiral arms, by the way. They're distributed completely throughout the disk. The spiral arms only look pretty because they have a bunch of bright, hot blue stars, but they're not really a lot more stars there than average. And so right there, you have a clue of where I'm going with this answer, which is if you just look at an elliptical galaxy, the stars are still moving in a circle or an ellipse, depending on the shape of the galaxy. They're moving around. They're not going all willy-nilly. There is still a defined pattern, a defined structure for the motion of stars. Even irregular galaxies, even the super oddball weird ones, will have some general sense of motion, but there will be large clumps of stars moving randomly because they're irregular and they're all messed up. But if you leave a galaxy to its own devices for long enough, it will develop, eventually the stars will develop these circular orbits. And that's it. Whether you're spiral, whether you're circular, doesn't matter. Astro B is asking over on the Space Cadets about these elliptical galaxies. Are they only ellipses because of the angle of our viewpoint? No, they really are elliptical. You have to remember, if you remember basic geometry, a circle is just a very special kind of ellipse. It's one particular ellipse where both sides are equal. The most gennaro case is going to be one side is slightly longer than the other, so you get an ellipse. So elliptical galaxies really, really, really are elliptical. Hence the name. It's not just a matter of point of view. Speaking of some more Space Cadet questions here, Java Man over on YouTube is asking, is the asteroid belt really a thing? We found 1 million asteroids stretching from beyond the orbit of Saturn to within the orbit of Venus, with many crossing the orbit of Earth. Yes, the main asteroid belt really, really, really is truly a thing. Yes, there are a bajillion asteroids everywhere else in the solar system, but there's a bajillion more in the asteroid belt. If you were to plot, say, average number of asteroids as a function of distance from the sun, there'd be like some asteroids, and then you get past Mars, some asteroids, and then you get between Mars and Jupiter, and it's like, whoa, a lot of asteroids. And then you get out to Jupiter, and it's like some asteroids. So there is definitely a spike in the population of asteroids in between the orbits of Mars and Jupiter, hence the name Asteroid Belt. It is a legit thing. That is a great question, though. The Rinstro is asking, what wavelengths of light did they use for that Japanese survey? I believe it was radio observations, radio or infrared, but I can do a quick fact check here because I am right here in front of my computer, so I can say Vera observations. And H2O Maser. Yep. So this is going to be in the radio infrared-ish range, which is the best for doing interferometers. So very good question. Thank you. Rinstro over on Twitch. Moving on. Yes, Rob Bowman over on YouTube talking again about Arecibo. I know it's cool and has been important, but would it be wise not to rebuild, but rather put money into more advanced radio astronomy resources? That's exactly my point. NSF was only paying a few $1 million a year for Arecibo. You can put that few $1 million a year somewhere else. I don't know, my pocket. I'm just tossing that out there. I don't know. I've done some radio astronomy work. I could get something done with a few $1 million. But maybe there's other things you can do with that. But yes, that's my point. There are better things we can do now in 2020 or 2021 than we could do in 1960. 1960 Arecibo was our best idea for radio astronomy. We have best ideas now. Cortos, along this theme on radio astronomy, I love this radio astronomy kick we're on today. What do you think of the square kilometer array being built in Australia and its smaller counterpart planned in South Africa? So I talked about this thing called interferometry, where instead of one big radio dish, you have a bunch of smaller ones spread out over a large area. And that's as if you had a large dish with that same width. So you get this incredibly high resolution. You do lose some things with interferometry because some of the light from deep space hits dirt and not your dishes, and so you don't get to collect that information. So you do have to play some tricks and fill in the gaps, but generally this is a very powerful technique. It's so powerful that what's being built right now is going to be the most powerful radio telescope ever. It's called the Square Kilometer Array. You do not get any points awarded for figuring out how large it is going to be in total area. It's going to be split in two parts. Half of it, and this is such a political decision, there were different sites competing to host the Square Kilometer Array. And the two contenders, one was in the desert of Western Australia, and the other contender was in the desert of South Africa. Guess who won? Both. So they split the array. Part of it is going to be in Western Australia. Part of it is going to be in South Africa. It is being built right now. It's going to cost a lot of money, like 5 billion euros, if I remember right, which is a lot of money. It's going to take forever to build. I have a general thing against large astronomy or just large science projects. I feel like $5 billion, yes, the Square Kilometer Array is going to answer a lot of very important science questions. If you spend $5 billion, you're going to end up answering important science questions no matter what. I personally believe this is just my own personal thing that we should be spending money on smaller projects, more agile, more nimble projects. Maybe we don't get to answer those big giant questions, but maybe we get to answer a bunch of smaller questions. Either way, science marches on. I don't know. That's just my take. I'm not necessarily. It's going to produce some great science. Don't get me wrong. And I know lots of people involved with the Square Kilometer Array. But I don't know, like 5 billion euro? Really? Is this the best use of 5 billion euro? Like, how much of that money is just going into infrastructure and politics and, I don't know, wire mesh when it could have gone to something else? I don't know. That's just me. I just have a general thing against large projects, but we can talk about that another day. SAHM on YouTube is asking, couldn't we make such a huge telescope in space? And the answer is no, because yes, there's a lot of room in space, which is fantastic. But it's hard to get stuff up there. It's expensive, and rockets are only so big. And so there can only be your telescope can only be so wide. Like, look what they're doing with James Webb Space Telescope, where they have to fold everything up like an origami flower in order to fit it in a rocket. And then hopefully it will expand and do everything right. And if it ever launches. Anyway. So, no, we can have these kinds of things up in space. It is much, much cheaper to do things on the ground. Now, Space Cadet Commander Benkai, who is not a commander in the Space Cadet Corps, just want to make that clear, it's a different branch, asking you need a cheese sponsor. Folks, I've got a cheese sponsor. Nancy, will you please hit up you already have. There you go. Nancy, you're fantastic. domscheese.com, DOMS cheese.com. Fantastic cheesemonger, purveyor of cheese. They source from around the world. Excellent selections. And they do ship. It's the holidays. It's time to eat cheese. If you need an excuse to eat cheese, like, this is it. And they provided a lovely cheese for me today. I'm so excited. I need to pull up the description here. Here we go. This is from a little cheese farm up in upstate New York, in Warrensburg, New York, called a Nettle Meadow Artisan Cheese. So go ahead and check them out. Nettle Meadow Artisan Cheese. And I'm eating today a Kunik. A Kunik. It's a small wheel here. I've got a little Kunik mini here. Kunik is a triple cream wheel made from goat's milk and cow cream. It has a white rind and a tangy, buttery flavor. The blend makes Kunik far richer and more flavorful than a brie-type cheese, and yet more subtle and sumptuous, love that word, than similarly ripened goat cheeses. Delicious on its own or with fruit and crackers. You know what? I'm not going to judge. You want to eat Kunik, you're going to do it however you want. A wonderful addition to any cheese plate. Cheesemakers describe it as a baby of butter and ice cream. Kunik, the baby of butter and ice cream, brought to us by Dom's Cheese, DOMScheese.com. My new best friends, as long as they keep the cheese rolling. And they're wonderful people, and they ship cheese boxes with a variety of selections. Look at this. Look at that rind, that white powdery rind. It's got some heft to it. It's denser than you might think. Oh, and it slices magically. This guy's been out of the fridge for about a half hour. I pulled it right out of the fridge right after. Now look. Oh my gosh, this is so amazing. This is so amazing. I'm going to cut it in half so you can see this. Wow. Hopefully you can see this on the camera. And if you're listening to the podcast, sorry, you're just gonna have to imagine this in your head. There's like two parts to the cheese, and I can't get the camera just right. There you go. You see there's like a yellowy outer region and then like a creamy whitish interior. That's the separation of the cow and the goat milk, and like, oh man. Okay, so this is supposed to be a combination, the baby, the unholy love child of butter and ice cream. Let's go. Wow. Now, I love a good brie. I love a good camembert. This is something else. It is so deep. It's like a campfire in your mouth. Not a hot, spicy, not like that, but just like a warm, cozy campfire in your mouth made of cheese. There's the butteriness, but you're right, that goat cheese tang is reduced. Wow. It's rich. Sometimes bries can get overpowerful, right? They can be like, hello, I'm brie. And this thing is just like much more so, like a warm, cozy campfire. That is a Kunik from Nettle Meadow Artisan Cheese in upstate New York, brought to you by domscheese.com. And you're right, Pavel. The sponsor's cheese will never be bad. I'll never make those mistakes like I did a few months ago, like buying bad cheese. Kirov099, before we go on Twitch, is asking, what equipment would you need to get into amateur radio astronomy? You can start with seriously like a car antenna. Like radio astronomy is so cheap. It is like sticks of wire. It is chicken coop cages strung over telephone poles is the cheapest stuff. What you can do that's really, really fun. You can get one of those old satellite dishes, the ones that are like a foot and a half across, like yay big, and just go to the junk pile and get it. These are microwave dishes. You can use it to pick up the sun, and you can pick up Jupiter. I'll look up like at-home radio astronomy kits, and you can get all the transceivers and stuff that you need to wire up to it. You probably aren't going to do a lot of like cutting edge science, but it's still going to be fun to see what you can detect in the radio. Chris sending some of that cheese as a gift to your parents. Perfect. Go on their website. If you don't see the option to ship, just shoot them an email. They're super, super accommodating. I mean, they're buying cheese for this show and contributing it. Listen, I got to cut us off here. What a wonderful show. Thank you so much, Space Cadets. I missed you over the past couple weeks because of the Thanksgiving break. Unfortunately, this broadcast is almost done. Thank you for joining me on this voyage of space radio. Once again, I'm Paul Starr, and this show is brought to you by you. Please go to patreon.com/PMStarter to learn how you can contribute. Thank you to Nancy Graziano for producing this show and wrangling the Space Cadets. Catch the live stream every Thursday at 8 p.m. Eastern. Visit spaceradioshow.com for more info, links to the live stream locations, the episode archive, the whole deal. You also follow me directly on all social channels. My name is @PaulMattSutter. And of course, thank you again, Space Cadets, for listening. See you next week. And remember, science is for sharing. End of transmission.